Good evening and thank you for joining me. As you can see, we have a high chance, a 70% chance of development for this disturbance here, Invest 95L. And it looks like most likely the track will take it across Florida like this. I don't think it's going to head into the Gulf, as some of the latest model guidance, in fact, shows a track northwest. Even some of them actually heading into potentially off the East Coast, a couple, like one or two of them. But most likely will take a track into the Panhandle. So this is more likely what will actually happen. So it's not going to be like this, but this disturbance is really worth watching, as there's a good amount of computer models that are predicting that this storm may actually threaten potentially the East Coast. It's this system right over here right now. It's on the Cape Verde at this moment. It's currently in the Cape Verdes and has a 40% chance of development through 5 days. And it's basically not going to develop. The system has no chance of development. This is Invest 94L. This is Invest 94L and this is 95L. Because this system got noticed first before this one. But as we go into look at Icon right now, look at that, a little disturbance there. Could become a subtropical storm here. This will likely go up the East Coast. May actually end up going into the Caribbean too, as this model indicates. A lot of storms for Florida. Well, I'm going to be there. And looking at the GFS right now, I have not looked at the GFS, but a lot of the models have it going up the East Coast. Make sure it's correct. Just want to make sure. Okay, we have only one person watching. That's probably me. Okay, save. Alrighty. Pretty good now. Now let's look at that model. Oh wow. This one has it going into, wait, is that last night's model? Because that's right now. No, that's last night's model. No, that's last night's run. Pretty big difference between this run and that run. I mean, this one had it. Three millibars. So this is the tropical storm that is to hit Florida. This is it right here. It's to hit Florida and then the Gulf Coast. this may be a threat to the whole East Coast, actually. 12Z doesn't even show this storm. Oh, there he goes. And look what it does here. Then it has to go right up the East Coast. Look at that. Look where it's going to be at 100 hour 114. Big difference between here and over here. And now let's go to model CMC. It looks like it's still having some trouble updating. But they're trying to pick up on that storm. Well, look at that, 1,004 millibars. That's, I would say, a 50-mile-an-hour tropical storm, and then its remnants. But this is the storm where you really need to watch. Look at that. And I'm going to be in Miami on the 16th. I mean, on the 17th. So, yeah. So I might be hit by that tropical storm. There we go. Analytics. And you know what? Also, let's take a look at Steamboat Geyser right now. Let's go ready for that. Let's look at Yellowstone right now. Earthquake activity has really been on the down low. No real earthquake activity the past few hours. Ooh, we had a 4.0 today in California. Not along the San Andreas. That's the thing. This is not a San Andreas fault, but it's one of the local faults. You had a 4.0 at 8.5 kilometers in depth. But no quake activity at Yellowstone. Completely quiet. But look at that. Norris Geyser is definitely having some significant activity, guys. Like, really significant. It's been continuously active. I mean, look at the past 30 days. Usually activity lasts maybe 3 days. See, usually picks up on the 18th and it stopped on around the 20th, around the 21st. So 3 days, not even 3 days, maybe 3 days. And here, this activity is lasting for more than like 4 days. It's already the 12th and it's still ongoing. This is the longest spike of activity we've seen. If there's going to be an eruption, it's going to be pretty significant because not only, okay, so the last eruption happened on the 3rd, and it's the 12th. 9 days pass and there's still no eruption, but look at that. You're not having the cyclical normal up and down. You're having continued activity at Norris Geyser. Continued activity at Norris Geyser. And look at this. So this started just before the 6th, and it's persisting. It's just continuing, guys. It just hasn't stopped. It almost took up the whole 7-day period of continued activity. I mean, I don't even know what Ben Furiello is saying about this, but he's probably pretty intrigued about this. to say the least. In fact, let's watch some of his latest videos. No update since about 2 days ago. Alrighty, last update is 2 days ago about him being wrong about an eruption. I mean, I was wrong too. I expected one that evening, and I was wrong. So, yeah, we were both wrong. And now there's a new thermal area in Yellowstone too. So yeah, Yellowstone's definitely becoming more active, but looking at earthquake activity, blank, none to speak of. And it's pretty quiet here. Looking at Hawaii, it's also pretty quiet. This is closer to Mauna Loa. This is between Mauna Loa and Kilauea. In fact, I'm gonna go to Google Maps. This is between Kilauea and Mauna Loa. So right in the Kapapala Forest Reserve, or Kapapala Forest Reserve, near Hawaii Volcanoes National Park. Let's check Volcano YT. I'm just waiting while I'm waiting for the GFS to load. I could check out some volcanic videos. Volcano YT is an amazing channel. Popocatépetl has limited activity right now, not much. And let's look at Mount Merapi from Yogyakarta. Normal mining activity. That's clouds. That's not any steaming or emissions, just clouds. You had a small scale eruption. That's, as you see here, that's mining activity there.
Dari Dusun Malang Desa.
No, those are forest fires, guys. Yep. Those are forest fires. Could be mining related. Could be intentional. Could be accidental. Yeah, that's definitely mining activity. Can't really find any earthquakes here. Yep, everything looks good. And let's go to Magma Indonesia to find any more activity. This is looking at seismograms. Ooh, looks like Agung had an earthquake. Yeah, that might be a small-scale eruption in Agung. Huh. So let's go back and try to... Yep, looks like Agung had an eruption. Did not see that coming. Alright. Because usually if it was at Merapi, or if it was an earthquake, they would not have that appearance. It was definitely an eruption at Agung. There's a lot of background noise, so can't even. That could be the eruption. That could be the quake. Yep, there it is. There's that event that caused that quake. There it is. Looking at the crater, I don't see any explosions or anything signifying an eruption. Let me fast forward just a little bit, a couple minutes, and no eruption, no. There's no plume or anything. So that was likely a volcanic tectonic earthquake, or a VT earthquake. And going to live, there's no other activity. That was likely maybe an earthquake related to some magma intrusion. And let's go back to the GFS. Look at that. GFS is showing 2 storms in one. That's a little odd, if you ask me. There's going to be 2. I mean, this is not very likely, guys, so just let's go to lower dynamics and look at MSLP anomaly, mean surface level pressure anomaly. Look at that high pressure system, but then you see that big storm over here? This storm will actually end up merging with this storm, as it will wind itself up according to the 18Z run. Yep. And this is completely different from what the current models are showing now. A lot further east here now, so righty. Wow, look at that huge difference west. Like, let's look at the euro now. Look where the euro had this storm at hour 168. Wow, I mean, look at that. Yeah, what I'm looking at right now is This is definitely a disturbance worth watching. This right now doesn't look like much, but see that over there. You know, anything could happen. Like the storm may not even materialize. It may end up, you know, doing not doing much. So yeah, look at that, a little miniature hurricane. So guys, thank you all for watching, and all right, let's look at the Storm Prediction Center. Actually, let's look at weather for this area right now, currently for Philadelphia radar. See if there's any storms. Okay, this is going to take a minute to load. You have too many windows open right now. Looks like all the activity has faded out. All right. All right, it was like a VT quake, and alrighty, not much going on right now. This is very unlikely to happen. I mean, the GFS is really though I definitely think you're right. About 95L in Florida. No, I mean, I would prepare for some gusty winds and heavy rain, but I don't think this is gonna do much. I mean, trust me, God, this does not spell like Katrina. Not right now. I mean, Katrina did look similar. In fact, let me look at its history, and I'll show you what I mean. Katrina was a disturbance that lasted a long time. It actually, they were tracking it for days before it even became a depression. So this is what it basically did. It came northwest, even almost briefly went north, and people thought it might actually go up the east coast. But then a really strong high built in, and it was pushed to the southwest. It actually became a hurricane as it entered Miami, and remained a hurricane as it went southwest into the Gulf of Mexico, went right over the loop current, exploded into Category 5. Thing is, we're not going to have that set up in place. Because here's the thing. As this storm is going to come in, you're going to have a high pressure building in, but it's not going to be extremely powerful like what happened when Katrina was there. And most of the models are taking this northwest right now. This will likely go out to sea now, I'm thinking. See how it's going northwest consistently? Look what this model is showing. This model is showing the storm going up the East Coast, not even into Florida. I mean, look at this model. Wow. Wow. This is definitely going to stink up the weather for Florida if this happens. Wow. Look at that. This is insane. It might very well just do that. Let's look at the NAM. The NAM definitely is not showing this. This is what the NAM is showing. Showing a tropical depression going into Florida and then going into the Gulf, but I'm not too concerned. And Icon usually sometimes overdoes the models. Steamboat Geyser is in Yellowstone, but it is not. Yeah, that's normal. Yeah, steamboat is just water. I mean, increased temperatures doesn't mean there's more it means does not mean it's gonna erupt. It just means that the water is seeping down further in where the water temperatures are hotter. In fact, you have hot springs in Arkansas. In Arkansas, you have hot springs. I don't even know there's a volcano in Arkansas. Also, unlike Yellowstone, the hot springs in these springs come not from volcanic activity, but from depth. Yeah. basically because of fault lines. There's water that seeps in and then it gets pushed back out because the fault is running upwards. A trip takes 4,000 years, while hot water takes about a year to reach the surface. Isn't that incredible? First winter storm formed last night, I think, for maybe the night before in the U.S. Yeah, in Canada there was a bit of a winter storm. Let's actually go back to the weather. Right now it's really hard to understand these models because they're all over the place right now. Yeah. You see this? You see what I mean here? Yeah. You see this here? This is what I have a hard time believing. Yeah, this is what I'm having a hard time believing. You're having a big high pressure system here. You're having these two tropical systems. I mean, this is just... I'm scratching my head right now, honestly. Yeah, this is just really confusing me right now. Like scratching my head confused. This, I think, seems more accurate. Finally, Canadian is starting to load. Oh, look at that. It actually may be heading up the east coast of Florida. Check that out. Huh. Hey. Welcome. Yep, I'm watching a developing tropical system. Alrighty, come on. right, let's look at the look at that. This model saying it's going to go up the East Coast. Ain't that something? Yeah, this is what's so confusing. This storm all the way near Europe is causing this storm to be sucked up towards Europe. Like, even though you're having a high pressure system here, it's like, it just doesn't make any sense. And you see this here? How in the world is this gonna happen? Like, how? I don't know what the GFS is doing, but it really doesn't make any sense. It's most likely gonna go west. This is one heck of a Fujiwara effect, guys. European makes a lot more sense than the GFS. Now look what the GFS's legacy is doing. This makes a lot more sense, guys. Right over Jamaica as a major hurricane. I mean, look at the Canadian. Holy crap, look at the Canadian, guys. Look at this. Look at the difference between GFS and GFS Legacy. Huge difference, like 1,000, 2,000 mile difference. Unbelievable. Like, and now let's look at the Pacific. Let's look at the Eastern Pacific. Now you have a hurricane in the Eastern Pacific. This is what the GEFS is saying. It looks like this actually may happen. I mean, look at this. One sec. Yep, steamboat erupted. Finally, we had not only an eruption, but a double eruption. Eruption, eruption. We had two eruptions. We finally had an eruption. Woo! Yep, I'm gonna post this on Ben Ferriero's Facebook. Save image as, save. And I'm gonna post this to his Facebook. He's gonna make a video tonight. It is only 9 p.m. for him though. Alright. Ferriero. And yep. Let me upload this to Twitter. And yes, Steamboat just had an eruption. And checking for the temperatures. Everything's gonna go back down to normal for Steamboat. But we just had an eruption. It's gonna have a big spike now to about 50 degrees centigrade. See if Twitter. Oops. Steamboat just had an eruption, guys, so. There's the eruption. See? Eruption and then another eruption. So basically it's a double eruption, and this is a prolonged one too. And it's still continuing. Yeah, looks like the eruption isn't over. Actually, the eruption is still continuing. let's go back to go back to let's go back to the seismogram. I just want to see. Oops. Yeah, U of U. Let's go back there. And yeah, the eruption is still continuing. It's basically still lingering. There you have the main eruption here. And then you have weakening, and then looks like another one. This one lasted for about, let's say 30 minutes, 20 minutes, a good 25-minute eruption. Then it weakened, and then it continued again. It's still continuing. See, here the seismo is very thin. Here it's thicker, so it's still definitely steaming. Yeah, this kind of does not make any sense, guys. Let's go to GFS Legacy. You're having a hurricane coming into Cuba, so Florida looks like it's going to be fine with this. Yeah, it looks like a Caribbean storm is much more likely now. And just let's look at some deformation. There's Long Valley Caldera boundary, Yellowstone Caldera boundary. There you go, magnitude 5. But let's go to the Caldera boundary here. And let's look at deformation here. This is basically the center of the research dome, and yeah, there is continuous uplift. This is only in 5 years, and look at that. About 2.5, -2.5 to +2.5. That's about 5 centimeters of uplift, which is a couple inches. Let's go about 5 centimeters, which is about 1.96 inches. Not too crazy, but there definitely is uplift, and the uplift looks like it's towards the southwest. Yep, it's southwest oriented uplift. So this area is bulging to the southwest. And this area is bulging to the, let's see, west. Also bulging to the southwest. And here the uplift is about, wait, I think that's the area that I chose. Let's look at here. Here the uplift is more towards the west-northwest, or here there's, let's look from about 2010. Here the uplift is from about 2014 It's also about 5 to 6 centimeters of uplift. So even here there's uplift. Let's look to the outer caldera boundary. Little to no uplift. And let's look to the southern part of the caldera boundary. Oops, that's the seismogram. And pretty significant uplift since 2012. So since 2014. That's about 2010. About from -4 to about, that's about 10 centimeters of uplift there. And let's look here. Some slow uplift, but it looks like it's frozen here. But in the middle of the caldera, let's look here. Also some slight uplift. No uplift here and around Mammoth Mountain. Northwest part of the caldera, very, very slight uplift. But some of the most impressive uplift is actually in the middle of the caldera. And look at that, teeny tiny earthquakes, constant small earthquakes. So nothing too crazy, but there is some earthquake activity there. So let's look at Long Valley over here. Let's look to the southeast part of the caldera. Also, there's uplift. Look at that. This is at about 2 centimeters, and so in about 2 years, that's about 4 centimeters of uplift. More. Uplift is also here southwest oriented. From about 2014 to now, there's about, say, 5 centimeters of uplift. Eastern part of the caldera, uplift too. Yep, definitely uplifting. Some uplift and then stabilization. So most of the uplift is in this area here. Southwest of the caldera boundary, there is deformation towards basically towards the west more oriented deformation, but not much uplift. In fact, it's pretty flat over here. So it's more towards the middle of the caldera, and that's not good. The fact that it's in the middle of the caldera itself means there's definitely uplift. This is not a hotspot volcano, which means it's not moving with the mantle. It's not moving with the crust. It's actually continued uplift because it's right in the middle of the resurgent dome. When will the eruption happen? We don't know, but the thing is, this volcano is considered very high threat because it erupts pretty frequently. It last erupted about 16 to 17,000 years ago. And I mean, its last super eruption, of course, was 760,000 years ago. It's actually not a super volcano because its last eruption was actually a VI7. See, 140 cubic kilometers, cubic miles. That's VI7 territory. Miles to kilometers, let's look, 140 cubic kilometers, which is about, that's definitely, let's say, VI7. VI7 to VI8, like like it. partially molten magma, congealed magma. These injections means it's produced by subduction. So look at that. A strong earthquake storm that included 4 magnitude 6 earthquakes that struck the southern margin of the caldera boundary. It was associated a 10-inch uplift. It was associated with a 10-inch, 250 millimeter dome-shaped uplift of the caldera floor. That is impressive. That's almost a foot. And that was not because of the quakes, that was because of magma rising. These events mark the onset of the latest period of caldera unrest that is ongoing. The ongoing unrest includes recurring earthquake swarms and continued dome-shaped uplift, which is occurring, of the central section of the caldera, accompanied by changes in thermal springs and gas emissions. After the quake, another road was created as an escape route. Its first name was proposed as the Mammoth Escape Route, but was changed to the Mammoth Scenic Loop after Mammoth area businesses and landowners complained. In 1982, the USGS and the Volcanic Hazards Program began an intensive effort to monitor and study geologic unrest in Long Valley caldera. The goal is to provide residents and civil authorities with reliable information on the nature of the potential hazards posed by this unrest and timely warning of an impending volcanic eruption should it develop. Perhaps all volcanic eruptions are preceded and accompanied by geophysical and geochemical changes in the volcanic system. Common precursory indicators of volcanic activity include increased seismicity, ground deformation, and variations in the nature and rate of gas emissions. So reservoir temperatures in the volcanic field declined from 428 degrees Fahrenheit near the Inyo craters to 128 degrees Fahrenheit near Crowley Lake due to combination of heat loss and mixing with cold water. Hot Creek has been a popular swimming hole for decades. Over a dozen people have died in Hot Creek since the 1960s, but most of the deaths happen to people who ignore the numerous warning signs and attempted to use the hydrothermal pools as hot tubs, like the stream portion of the creek. These pools alternate in temperature, but the eruptions in the pools of superheated water in already very hot water. Recent geothermal instability has led to its temporary closure for swimming. Officials are unsure of when, if ever, Hot Creek will officially reopen for swimming. Wow, so that's not good. Hydrothermal activity has altered many rocks in the caldera, transforming them into travertine and clay. At the Huntley clay mine, white chalky clay called kaolinite is mined. The kaolinite is exposed on the resurgent dome and appears as a brilliant white band. Wow. And let's look at eruptions. See? VEI-7 eruption. Most VEI-7 eruptions are produced by stratovolcanoes, aka Tambora, aka Samalets, which are stratovolcanoes. But the thing is, Long Valley is not shaped like a stratovolcano. It is shaped like a caldera. Crater Lake in Oregon, a stratovolcano, is also VEI-7. And look at that. It started by erupting rhyodacite, which is the same volcano that caused the climatic eruption of Crater Lake in Oregon. It also erupted rhyodacite. Rhyodacite often exists as explosive pyroclastic volcanic deposits. Rhyodacite lava flows occur, for example, in northwestern Ferry County in Washington. And let's look at the GFS legacy now. Alrighty, let's look at Long Valley. Oh yes, and look what Forbes found. Yeah, 240 cubic kilometer miles of magma. Uh, man. So let's see. Long Valley is actually not a supervolcano since VI8 is supervolcano. So the Long Valley volcano. Oh. Banana K. place is right on the beach. Long Valley caldera is a depression that formed from the volcanic eruption 760,000 years ago, which ejected hot ash, lava, and toxic gas. The eruption 760,000 years ago erupted 140 cubic miles of material from the volcano. So yeah, it's VI7. If all of the 240 cubic miles of magma beneath the Long Valley supervolcano were ever to erupt, if it would eject over 800 times the volume of material as Mount St. Helens eruption.
Coalition of 5 space agencies: NASA, Europe, Russia, Japan, and China. And we'll add to that. And with fuel on the moon, we can have other countries go to the moon much, much easier.
Yep, this is actually a Long Valley right here. And that's the uplift right there. This is basically most of California. This is the caldera here, and that's that dome. That's a resurgent dome as well. Look at all that uplift there. Oh, Buzz Aldrin. Alrighty. Let's look at the Canadian now. So look what the Canadian is showing. Look at that, showing a tropical storm right on the Carolina coast. And then look at that. Look at that, and then a double whammy right into Miami. I'm gonna get soaked. Man, I'm glad you're safe now. I'm so sorry about that, man. And let's look here. And look at that. Some of the models are actually saying it's going to go northwest. I'm glad you're safe. Let's look at magma Indonesia again. Haven't checked that in a couple hours. Let's check. Or you had a small volcanic tectonic earthquake here at Agung. No problem, man. That's actually from the volcano from the live stream I'm watching. Oops. That blow up of convection there. let's look at this now. Let's look at the let's look at space weather. 8 days of no sunspot activity. I'm gonna look at the right. Let's look at GEFS right now. temperatures are currently. Oh, look at that. There's a bit of an eruption. Look at that, it's actually having a little plume coming off of it. Alrighty, let's look at Iceland. Okay, looks like Iceland is having some pretty big earthquakes right on the Reckness fracture zone. Well, Reckness Ridge, actually. Right on Reckness Peninsula, there's been some quakes. Nothing impressive here. It's good, a couple of quakes here, but nothing impressive. Yeah, it definitely looks like a volcano. Let's see. Yep, the eruption. It's still continuing. Look at those steam-driven blasts. Blast, 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 blast. Still waiting for Ben to update a video.
It's been quite a few months of activity in Yellowstone National Park. Steamboat Geyser, the world's tallest, is approaching a record number of eruptions this year. And last month, Ear Spring, dormant since 1957, erupted with some surprising results.
I got there just after the eruption, and it was pretty amazing what I saw.
After the hot spring belched water up to 30 feet in the air, park officials found this: piles of man-made debris.
There was an incredible wash. The water had just washed out under the boardwalk and had strewn trash all around,
including a cement block, cans, dozens of coins, and a baby's pacifier that dates back to the 1930s. The trash is being cataloged now and could become part of Yellowstone's archives as a reminder to the millions of visitors to not use the park's natural wonders as a dumping ground.
You might think that if you toss something in a hot spring or in a geyser that it kind of disappears, but it doesn't disappear. It stays in that, and what normally happens is you can actually plug up a feature and kill the feature, and that's happened in many places in the park.
Killing many places, killed in many places in the park.
That's one big giant belch, that was.
Yeah, it was.
That's one way to look at it.
Concrete, pacifiers, coins.
What else is in there?
Yeah.
Isn't that something? Alrighty. Well, I think that's all for tonight. I may continue.
Lesson.
Some great video to show you here. The U.S. Geological Survey says Steamboat Geyser has experienced its third water eruption in the past 6 weeks. USGS says Steamboat began erupting about 6:30 in the morning on Sunday, still going strong as of 5:30 Sunday when MTN paid it a visit. This is what it looked like, sending a huge steam plume into the air with water shooting 50 to 60 feet high. Of course, this is not a major eruption for Steamboat. It's the largest currently active geyser in the world. A major eruption can send water 300 feet in the air. USGS says this is the fifth eruption of Steamboat this spring, may signify a period of greater activity. This happened once before back in the 60s and then again in the early 80s, but scientists say they don't think these Steamboat eruptions in Yellowstone in general is about to enter an active volcanic phase. Steamboat is highly variable, sometimes going years between eruptions. At one point didn't erupt for 50 years. So get down there and enjoy it while you can.
That's pretty
Our own
cool.
John Shear bringing us that video from the
That
weekend.
is awesome.
That's
I've never been patient enough to hang out long
It's
enough.
awesome. Yeah. Well, for years it was not. There was no activity, just
Yep.
a little bit of steam vent. So it's been
Pretty
a good year
cool.
to
And
get
that
out.
area of the park is so pretty.
Love it.
Of
My
course.
favorite place.
Of course. Of course. Your favorite spot.
Yep.
Good morning to you.
eruption in particular touched deep into that, just with the unbridled glory and majesty and power, and the eyes are filled with tears again.
Steamboat Geyser erupted for the 7th time this year. Unlike Old Faithful, that Yellowstone can predict within 10 minutes, nobody truly knows when Steamboat Geyser will erupt.
I had such high expectations, and I missed the mark by a million miles. I am a satisfied person. My heart is full. My cup is overflowing.
So John Warnock posted up and patiently waited on the world's largest geyser.
Got out here at 5:30 on Sunday morning, spent the day until 7, and then we returned this morning at 5:30.
Because at 9 o'clock, Steamboat Geyser started showing signs of life.
Boom, took off.
I showed up a little bit late and only caught the tail end, but John got to see Steamboat Geyser in all its glory.
Both vents opened up. The water was going at least 300 feet, maybe higher.
It's a moment and a day that John Warnock will never forget.
And I just feel so blessed. The Lord loves me an awful lot to let me see it.
Steve Dent, 6 on your side.
Steamboat Geyser in Yellowstone National Park has tied an all-time record for eruptions in a single year. The geyser had its 32nd major eruption of the year Tuesday afternoon. The previous record was set just last year when the geyser sprang to life after being dormant for more than 3.5 years. Last year's record, the longest in recorded history, was set on Christmas Day. With more than 4 months remaining in this year, there's a distinct possibility the geyser will break its record for eruptions in a single year. But scientists at the Yellowstone Volcano Observatory tell MTN News Steamboat is unpredictable. It could stop erupting at any time. Get this, it once quit going off for 50 years from 1911 to 1961.
I actually agree with that forecast. Big coastal storms, worse the winter, because you're having a very negative NAO. You're going to have a very negative NAO, very positive PNA this winter because of warm Northeast Pacific. Actually, I'm going to go into a little bit of winter forecasts right now. So as we go on right now, so you can see all the warm water here in Northeast Pacific and all the warm water here in Labrador. Things are showing signs that this winter is going to be very cold and snowy. This is definitely going to be a cold and snowy winter, guys. Here's a good sign of that. I mean, yeah, look at it. It's going to be pretty cold and snowy this winter. so this seems more likely now, guys. European has it here. Oh man, I'm getting excited now. So looking at sea surface temperatures, yeah, this one's just gonna be very cold and snowy, guys. Just letting you all know. Water temperatures are still in the 80s here. Water temperatures still in the 80s. Wow. Still in the 80s. Temperature 71.4, 72.1. The temperature of 73.8. Here it's 67 degrees. Water temperature of 76.5. Wow, that's warm. Reed Slave Lake 53.6, 51. Yeah, 60.4 degrees, and let's look here. Lake Winnipeg. I don't know if that's actually correct. Yeah, that's pretty warm. Let's look at the weather for tomorrow now. Let's see. starting in 1992 and increasing in 1998. A 70-kilometer wide circular region around Uturuncu has been deforming at a rate of 1 to 2 centimeters, or between 4/10 and 8/10 of an inch a year, with a center 3 kilometer with a center 3 kilometers from the summit of the volcano. Research has indicated that the sources must be deep to create large-scale ground inflation above the partially molten layer of the APVC partial melt zone. A ring of subsidence surrounds the uplift and expands the size of the deformed area to a diameter of 150 kilometers. The subsidence occurs at a rate of 2 millimeters a year. Wow, total volume changes over 14 years amounts to 40 billion meters cubed, or 1.4 times 10 to the 12th power cubic feet, at a depth of 17 to 30 kilometers below the surface. Magma accumulation of 0.01 cubic kilometers per year have been estimated. These inflation and accumulation rates are comparable to the inflation rates at Yellowstone caldera and Long Valley caldera, and the Lazufre and Las Terra Cerro del Azufre in Chile. Let's see what that is. Ground deformation. Oh wait, that means this actually may become a super volcano. It's 1 to 2 cubic centimeters a year. Another anomalous seismic activity has also been observed in the center and centered in a source of 3 to 4 kilometers deep and 4 kilometers southwest of the summit. Microseismic activity was also registered, such as Mist City exceeds that of other volcanoes in the region, with the exception of Lascar during active periods. And let's see. Lascar usually erupts, so exceeds other volcanoes in the region, with the exception of Lascar during active periods, and Lastaria and San Pedro, and is likely to be normal background activity for the area. Some earthquake activity and seismic swarms were triggered by the 2010 Chile earthquake and may be indicative of unstable hydromagmatic systems or interactions of the magmatic system with far-field earthquake waves. Hypotheses regarding the earthquake activity either consider shallow faults deforming in a brittle manner, groundwater movements, or a combination of these with a disturbance of a hydrothermal system. So the APVC stands for the Altiplano Puna Volcanic Complex. The presence of partial melts below the APVC suggests a magmatic origin of the activity. Wow, that's not good. Gravimetric data indicate that a vertical, low-density body connects Uturuncu where was I again before I got interrupted? Gravimetric data indicate that a vertical, low-density body connects Uturuncu with the APVC magma body at a depth of 25 kilometers. Several such bodies with a radii of 12 to 20 kilometers are found beneath the APVC, or the Altiplano Puna Volcanic Complex. 2013, Del Potro estimated that this body may contain 25% of molten dacite. The exact shape of this body is unknown due to insufficient resolution of the gravimetric and magnetotelluric measurements. The formation of buoyant mobile layers following heating may destabilize this magma mushing, cause lava to accumulate a few kilometers below the volcano and erupt. The magma intrusion rate below Uturuncu is considerably larger than the magma output of the Pleistocene volcano, being comparable to the magma flux of historic eruptions and estimates of magma generation rates in local caldera-forming magma chambers, which is not good, which means this could become a super eruption. Evidence for the formation of such a magma chamber is elusive, but might be hidden by the deformation activity of the APVC melt generation zone. Uturuncu may be developing into a supervolcano, and a caldera-forming super eruption may occur there. This possibility has resulted in international media attention. However, there is no evidence of eruptible magma near the surface, meaning that such an eruption could not occur in the near future. Let's go back to the European model now. Oh, look at that. Look where the European has the storm. Oh, yeah. Oh, wow. It looks like we might get an East Coast hit now. Oh, wow. Oh, great. It looks like it may go up the East Coast instead of into Florida. Looks like, guys, this may actually not happen. It actually may go up here. And one thing the European is very good at is anticipating the track of tropical cyclones. Look at this.